Well, welcome back, ladies and gentlemen. In this video, we are going to continue our discussion on vectors. Specifically, the goal of this video is going to be able to find a direction angle of a vector. And along with the magnitude as well, too, because we're going to have to find the magnitude to find the direction angle here. So if you remember correctly, in our previous video, we went ahead and talked about how we can represent the vector in a different kind of component form, if you will, right, by utilizing the cosine and sine of the direction angle. The direction angle, once again, just remember, kind of almost tells us what quadrant, if you will, is the vector in and of itself. So let's take a look here at example A. It says that we have a vector u that is 3, 2. So let's go ahead and take a look here visually, first and foremost, of what this actual vector is going to look like. And so first and foremost, if I have 3, 2, that means that I went horizontally 3 units and then up 2 units. And so that means I'm going to be in quadrant 1 for my vector. So this kind of shows us that we understand that, I'm going to call it theta for right now, that the theta, the direction angle that we want to find, ends up being an acute angle in quadrant 1. So for part A, we know that u is equal to the square root of 3, not square root, is equal to the component of 3, 2. But due to what we learned in our previous video, we also know that we could rewrite this as the component of the magnitude of u times the cosine of the direction angle, comma, the magnitude times the sine of the direction angle. And so let's go ahead and find out what that magnitude is, because I really only need my 2 components to find that magnitude. So the magnitude of u is going to be the square root of 3 squared plus 2 squared, giving us a square root of 13 for our magnitude. Well, now what we end up doing is we put ourselves in a scenario where we can go ahead and utilize our inverse trig functions and our values of our component form to solve for a missing angle. So I know that the actual component of the horizontal component of this vector is 3. But I've also already stated that that horizontal component also equals the magnitude times the cosine of the direction angle. And so the magnitude is the square root of 13 multiplied by the cosine of theta. So I can go ahead and utilize this information to use our inverse trig functions and ultimately find out what that angle is. Now, the reason why I'm choosing to utilize cosine is because of our restricted domains. I'm about to take the inverse trig function here for cosine. Now, I know this would work fine using sine as well too, because it's an acute function, but I'm just going to go ahead and use cosine. 1, it's first on the list, and 2, for some reason or another, it just kind of seems to be a safer bet sometimes when students are dealing with these inverse trig functions, because remember, our restricted domain for cosine is from 0 to pi, and then for sine it's from negative pi halves on to pi halves. Again, regardless, in this case it would be the exact same thing, but in just future reference, and you'll see it maybe a little bit more when we look in our example B on this problem as well too. So I know that the cosine theta is equal to 3 over square root of 13. So that means that theta is the cosine inverse of 3 over the square root of 13. And again, because this fits our restricted domain, no problem, we're going to go ahead and easily get 33.69 for the direction angle of our first vector there. Now I encourage you, go ahead and try to pause this video now and see if you can do part B on your own. I will continue on and maybe you want to come back and see if you did it right. So let's take a look here at our direction for, our example for part B. So for part B, we want the exact same concept. We want to go ahead and be able to find the magnitude and the direction angle for the vector V. And in doing so, we're going to basically do the exact same concept, just have to take into a little bit of a different aspect. So let's think about this once again in terms of our coordinate plane, right? If I'm going -2, that really means go left 2 units. And if I'm going -5, that really means go down 5 units. So what that tells me is that my vector V is going to be in quadrant 3. So that means that my direction angle is going to be in between 180 degrees and 270 degrees. So when we're doing this, we just have to kind of keep in mind as to what angle we are actually going to be finding when we use our inverse trig functions to find out what that angle is. And so let's think about this for a second. If we have our V equal to -2, -5, we know that our component form can also be written as the magnitude times the cosine and sine of each of the respective components. So let's find that magnitude first and foremost. The magnitude of V is the square root of -2 squared plus -5 squared, which is going to give us the square root of 29. So I'm going to rewrite this as the square root of 29 times the cosine, I'm going to call it theta sub 1 this time, and square root of 29 times sine of theta sub 1. And so if you really kind of think about this, if you just go ahead and set up an equation of -2 equals the square root of 29 and get cosine theta, now I wouldn't necessarily write this down or anything like that, but just let's kind of put this into perspective. If I go ahead and solve for theta sub 1 as being the cosine inverse of -2 over the square root of 29, if I go ahead and do that, I roughly get about 111.8 for my degrees. So obviously that's going to be in quadrant 2. So that's not necessarily going to be an accurate description because we know that this direction angle should actually be in quadrant 3 based on the components of -2 and -5. So really what we need to take into account is that if this is our entire component -2, -5 in quadrant 3, and our angle is producing the degree from 0 to pi or 0 to 180 at 111.8, the question I have is, well, what would you have to do to put it into quadrant 3? Well, hopefully you understand that all that we would really have to do is take 360 degrees and subtract our cosine inverse that we just got at about 111.8. So really theta sub 1 would end up being 360 minus cosine inverse of -2 over the square root of 29. So really it's 360 minus that 111.8. And so that roughly comes about to be about 248.2 degrees. And again, we had to make these kind of adjustments because of where the direction angle was. It was in quadrant 3. By just doing the cosine inverse, that put us in quadrant 2, but that is not where the vector led us using -2, -5.